On Monday, we did section 6.1.2, and I don't think we wrote down our learning target on Monday. So could you go ahead and get this down on the front of your packet? The big question from Monday was, what are the triangle congruence conditions? These are those shortcuts that we talked about on Monday. If you remember on Monday, we talked about how SAS is a triangle congruent shortcut. And then on Monday, I told you there were 4 more, and I gave you 6 examples, and I had you figure out which 4 of them worked. Do you guys remember doing that on Monday? We put some notes in our packet, and I want to go back to those notes, both for the people who were not here and for those of us, because it was right at the end of the period, and I feel like we didn't really do a whole lot of time explaining. So this is right in your packet, right on the next page. And did we draw these pictures? We drew the pictures and we wrote it out. Okay. I want to remind you about a couple things that I need you to know about. So number 1, for SAS, do you remember it back in chapter 3, there was something special about SAS similarity? There was something special about the A. What was special about the angle if we were going to use SAS? It had to touch both sides, it had to be between the 2 sides. The A had to be touching both of them, right? And we need to see that in the picture too, that the angle is touching both sides in both triangles. If that's not the case, then it's no longer SAS. Then you've got either SSA or ASS. We cannot use those, they do not work. All right, so just a quick reminder, and I'm going to just make myself a note here. I'll write it out in words because every time I write something down or I read something, it does help me remember it more long term. I'm going to say the angle must touch both sides. So that was probably the biggest tricky thing in chapter 3 when it came to these shortcuts, these conditions. We had SSS in chapter 3 also, but you guys didn't get tripped up by SSS that much. It's pretty straightforward, right? You got all 3 of the sides or you don't. Nothing really tricky about that. We did not talk about this on Monday, but ASA has something tricky about it too. What do you suppose it is? Yeah, exactly. Just like with SAS, see how this time we've got the S in the middle that's touching both of the A's in the name? Well, in the picture, we got to see the same thing. The side that is marked, this side right here, has to be touching both of the angles in both of our pictures. And if that's not happening, then it is not ASA. You okay? So I'm going to make a note on this one also. This time it's the side that must touch both angles. By the way, this question came up earlier today. My students were asking about the markings on the angles. I'm just going to put this out in the margin. Do you guys know what it means when I have 2 angles that are marked like that? Close. They are similar, actually. We can go a little further than that. They're congruent, okay? This means that they're congruent. Do you know what it means if I have angles that are marked like this? That means I got another pair that's congruent. But are these 2 the same as these 2? No, so these 2 are the same. And these two are the same, but these two are not the same because they have different markings on them. What about if I had something like this? What does that tell you about these two angles? They are congruent. These are all just ways of marking congruent. Okay. And these two are congruent to each other, but these two are not because the symbols are different. You get what I'm saying? So you're going to see single arcs, double arcs, triple arcs. I think we'll run into a problem at the end of the year where we've actually got like 4 arcs on it. Okay. Or you might see some arcs with ticks. So they might have a single arc with 1 tick or a single arc with 2 ticks. But all that they're telling you there is that if that angle, if you see another angle that has the same markings, that those two angles are congruent. Are we cool with that? That came up in my class on Monday, so I want to make sure we cover that. Or sorry, not Monday, on first period. Okay. AAS. Isn't that kind of the same thing? They both have 2 angles and a side, right? But what? Say one more time. So this one, good. You're absolutely right. And this one, the side is not touching both of the angles. How many angles is the side touching? Only 1. And look in the picture. See how this side is only touching one of those angles? This side's not touching this angle, is it? So in AAS, and you're free to call it SAA if you prefer. In this case, the side only touches only 1 angle. Now I know I got a handful of people in here who are really good at metacognition. You guys know what that means? Metacognition. Meta means when you like do something about itself. Like a meta song is a song about writing songs. Okay. A meta play would be a play about plays. Have you ever seen a meta film? A movie that was about making movies? Okay. So metacognition is, cognition means thinking, right? So metacognition is thinking about thinking. So I know, and it's something that develops. All humans develop metacognition over time, but it's one of the later things that develops. So for a lot of people, it's not till like your 20s you really start getting good at this. But I know that I have students that are good at a younger age. So some of you, those of you who are good at thinking about your thinking, are probably going to look at these and say, you know what? I better keep an eye out for these two because they're awfully similar, but it would be easy to mix them up. Was anybody thinking that to them or that to themselves? Yeah, they would be, wouldn't they? They both have 2 angles. They both have 1 side. It would be really easy to mess them up. And those of you who are really good at metacognition will go a step beyond that and say, what strategy can I think of that I could help to not make that mistake? Anybody have any ideas? What are you thinking? Mm-hmm. Awesome. Yeah, that's great. So your strategy is to sort of come up with an explanation in your mind that you can sort of repeat to yourself when you run into the situation to figure out which one it is. That's a great strategy. The strategy that I use is if I run into something with 2 angles, I'm going to double check it. That's my strategy. I've made enough mistakes with these two that as soon as I see a problem that's got 2 angles in it, I'm just going to double check. Is the side touching both the angles? That's the big question, right? Or is it only touching one? All right, cool. And then we talked about HL, which is kind of the weird one, but I really like this name. Whoever came up with this term actually put some thought into it because this only works for right triangles, correct? Did we talk about that on Monday? And that's great because the only type of triangles that have a hypotenuse are right triangles. So when you see HL, as long as you're thinking hypotenuse leg, you're never going to make the mistake of trying to apply this to a triangle that's not right. because you have to have a 90-degree angle in order to find a hypotenuse, right? That's what the hypotenuse is. It's the side across from the 90, right? So this works because it has a hypotenuse and a leg, and a leg is a term that we use for the other two sides in a right triangle, the ones that aren't the hypotenuse, the A and the B, and A squared plus B squared equals C squared, right? So we've got to have a 90-degree angle, we've got to have the hypotenuse, and we have to have a leg. I think we talked about on Monday the reason why this works is because you could find this third angle using Pythagorean theorem. And if you found this missing side and this missing side, wouldn't they have to be the same? Because you're going to use the same numbers in both equations, right? So really, this is kind of a special case of SSS, but we're going to write HL for it. All right, you guys are doing great with this. I'm going to give you a couple examples of the types of problems that we're going to work on today. And, you know, I started doing on notebook paper first period. Someone suggested, why don't we put these in our other notes right in our packet? So we've got some examples. So I thought that was a good idea. So that's what I'm going to do. So could I get you guys, whether you want to put it in your notes or if you want to put it on this page in your packet, I'll let you make that decision. But could you guys copy down a couple pictures for me? The first one looks like this. It's got a vertical line with a triangle on both sides. Kind of looks like a kite. Well, it was supposed to in my head, but. And that was supposed to be a little bit more symmetrical than that, but that's all right. And I am going to ask you to mark a couple of angles in these two triangles for me. We're going to mark this one with a single and this one with a single. We'll do a double right here and we'll do another double right there. And my question is, are these triangles congruent? Now they don't look congruent because I drew them pretty wonky, but that's all right. We don't trust what we see in the we don't trust the way it looks. We trust the information that we see in the drawing. Now, last week, almost all of you were starting to get really good at recognizing a piece of information that is in this picture but is not marked in the picture. Does anybody know what I'm talking about here? Anthony knows. Zoe knows. Carly knows. Good. Jacob, what was it? They share the same size. Is that what you guys were thinking of too? So, and I can go ahead and mark that with a tick mark. So go ahead and put that in there. It wasn't original information, but that's information I was able to add in because this side is the same for both triangles, right? Okay, well, hang on just a second. Let me catch up. We'll see if we agree. Now, the other thing that I told you last week, and this is going to be really helpful to some of you today, when you're trying to figure out your reason, I want you to try this out today. Try covering up one of the triangles, just looking at one triangle at a time. So I'm looking at that left-hand triangle, and then do a little inventory. What do you see there? Do you see any angles marked? How many? 2 angles. How many sides? 2 angles and 1 side. So that's got to be, if we think back to those 5 that we just wrote down, that's either ASA or AAS, right? Which one is this? ASA or is it AAS? AAS. So the question that we ask ourselves, is the side touching both of those angles? Is it? It's not. So it's not ASA. It is AAS. And don't forget your little congruent symbol after your AAS, because AAS similarity is not a thing. Now I could have covered up the other side and I would have also seen 2 angles in a side and the side's not touching both angles. Okay, now I got to say something real quick because this question came up first period and I guarantee someone out there is thinking it right now. Can I get you guys to look up at the screen real quick? Was anybody looking at these 2 triangles and said, wait, that side is touching 2 angles? Did anybody notice that? And think because of that it was going to be ASA? Okay, yeah. And that is a super common mistake. So when you do this, it's not that the side has to touch two angles. It needs to touch both of the angles in a triangle, not in two different triangles. This side is touching both of these angles, but they're in two different triangles. Okay, so that's why it's really helpful to cover up one of your triangles. So you're only focusing on one triangle at a time. And then we can easily see that this side is not touching both of the angles in this triangle. You see that? All right, I'm gonna give you another one here. See how you guys do with this one. So this is kind of a complicated picture. Go ahead and draw me an X. And we're going to turn it into two triangles by connecting it on the sides here. And I'm going to have you mark some angles and sides here. We'll do this angle, that angle, this side, and this side. And we're going to ask ourselves the same question. Are they congruent? And if they are, what reason could you use to prove it? So which of those five? Now, again, once again, we do have a vital piece of information that's in the picture, but is not marked yet. And this is the one that I'm really hopeful that you guys are going to get super confident with. I told you back in first semester when we learned this, I was like, you guys are going to see this again and again and again and again. Carly, what was it? Vertical angles. How many people saw vertical angles as soon as I drew this thing? Good for you. We have these two angles here. Now I've already used single arcs, so I got to go double. But these two angles here are vertical angles, and vertical angles are always congruent. So even though that information was not marked in the picture, we could add that marking ourselves. And we'll use our little strategy again where we'll cover up one of the triangles and ask ourselves, what do we got here? So take inventory. I'm seeing a side and two angles again. Is that what you're seeing? Is it ASA this time? Is that side touching both of those angles within the same triangle this time? This side is right next to this one and right next to this one. It is ASA. Just double check on the other side and make sure it's the same. I'm seeing two angles, the sides touching both of them. Good. One more together, and then you're going to do a whole bunch of them with your table partner. Same question as before. Are they congruent? What reason? But before that, the first question we really should be asking ourselves is, what else can we mark in this picture? Jacob's got an idea for us. Ooh, that's a great one. So we haven't talked much about this. I'm super happy you noticed that. Jake, and I really like the way you said that. You said since the triangle on the left is a right triangle, that means that this has to be a right angle over here also. You guys see why that is? The right angle means these are perpendicular, and these being perpendicular means they're all right angles, right? So we have another right angle there. Ooh, right triangles. What's right triangles make you think of those five that we had on the back of this sheet or on the other side? Makes me think of hypotenuse leg, but let's make sure. Is there anything else we can mark in this picture? We've got these guys here for sure are equal to each other because they're a shared side, kind of like they were over here. Hang on just a second. Let me mark this. I'm doing double ticks because I've already got single ticks on there. All right, we have a conjecture that the hypotenuses are also equal. How do you know that? Why though? I mean, this side and this triangle is equal to this side and this because they overlap with each other. You don't know why it's the way it is, but it's the way it is. Ooh, that's an interesting thought. So Anthony is saying that we've actually got SAS going on here. Do you agree with him? Because these are both marked 90, which means they are the same, right? And that angle is in both triangles, that angle is touching both sides. Could we do SAS? Okay. I'm going to go ahead and write SAS because we seem to all be agreeing on that. Now the question is, could we use hypotenuse leg? And I'm going to tell you a short version of that is right now, no, we can't, because we do not have any way to know for sure that these two hypotenuses are equal. Now, Parker, you're thinking a step ahead. So we're actually going to get, when we get into the end of this chapter, we're going to talk about how we could look at these two triangles and show that they are congruent by SAS, right? So good on you for noticing that. And then once we know that they're congruent triangles have all matching parts, which means these are going to end up being congruent also. And we'll learn this thing called CP/CTC that allows us to do that. So you're already thinking a step ahead of that, and that's awesome. But for Parker, for right now, I need you to focus just on what is marked in the picture and what you can definitely mark because of things like a shared side, vertical angles, or perpendicular lines always having a couple 90-degree angles. And try not to take that extra step ahead just yet. Feel free to think about it, but we're not going to use that just yet until we've learned the formal ways of doing those, okay? All right, so here's what we're going to do, guys. Pay attention. Let me give you instructions. I want you working with a partner on this. So if you're sitting at a table by yourself, you're going to need to find someone else who is, and I can gladly help with that. I'm going to give each table a sheet that's going to look like this, and it has 3 pages. Guys, please pay attention, because this is what you're doing for the rest of class, okay? And I'm not going to explain this again. You guys with me? Parker, pay attention. You're going to have 3 pieces of paper, and each of them has 9 cards on it. How many cards is that altogether? 27 cards, and you'll notice that they are not cut out yet. You're going to need to do that. There's a whole bunch of scissors over there. You're just going to get 27 cards per table. Go ahead and in a moment, when I say go, send one person over to grab 2 pairs of scissors, and then you can divide and conquer, right? You can share the cutting out piece. You're going to make these cards, and then I'm going to ask you to sort the cards into 6 stacks. And those 6 stacks are going to correspond to these 6 places on this sheet. Now, we didn't write anything here. What do you suppose is going to go in here? Not congruent. So anything that doesn't work with any of the other 5 are going to go in here. And there are some in your 27 that are going to be not congruent or not possible. Okay, so step 1 is get them cut out. And then with your table partner, start sorting them. And you can feel free, because this is your copy. So if you get a problem like this one right here, and you want to go ahead and put a tick mark right here to let you know that, oh yeah, those are congruent, even though they're not marked, you can do that if you'd like. Okay, so feel free to mark on these. All right, and that's going to give us about 20 minutes or so until we're going to have to start packing up. So 2 people or 1 person from the group, come over and grab 2 pairs of scissors. 1, 2, 3, go. I'll be around to give you the cards. Yeah, thank you. You'll have to join up with who we got. Mandy's doesn't have a partner. Do you mind grabbing the scissors and taking them back to that back table, and take this sheet with you too? That'll work out well. Okay, we're gonna want to work kind of quickly here. Got about 15 minutes or so. Actually, I think that might be just enough. We'll come back together here in about 15 minutes. I'll give you some answers and you guys can check and see how you did.